Hi friends, this is the lecture number 7. Okay, in this lecture number 7, today we will discuss about basis. Actually, what is basis? So, to come in this lecture, I will just request you, you must go in the linearly independent. This lecture we have created, okay? You must go in the lecture numbers 1, 2, 3, 4, 5, 6. Then you will understand actually what is the linearly independent and what is the span, okay? So again we are just proving if you want to just show some vector basis, then at first you have to show that these vectors are the linearly independent and these vectors are also spanning any vector, okay? So now at first we will just check that linearly independent. So what we have told you in the previous lecture, okay, if the linearly combination of the vectors and scalar is equal to 0 and if all the scalars are 0, then it will be linearly independence. Okay, what we are talking? Alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3 plus alpha 4 v4 is equal to 0. Okay, that is the linear combination. Here this is v1, this is v2, let, okay, v3 and v4. Now we have to prove this alpha 1, alpha 2, alpha 3 and alpha 4. If all scalar, these alpha 1, alpha 2, alpha 3, alpha 4, these are the scalar. If all scalar is equal to 0, it implies that this is the linearly independent. Okay. So alpha 1 into, we will put this here, 1, 0, 0, plus, after then plus alpha 2, we will put this here, 1, 1, 0, plus alpha 3 we will put here 1 1 1 plus alpha 4 we will put this here 0 1 0. Okay, this is equal to 0. Now this will multiply here, you will get alpha 1, okay, then comma 0 0, okay, alpha 1 into 0 is equal to 0 plus alpha 2 0, then this will come here plus alpha 3 alpha 3 plus 0 0 alpha 4 0. Okay, this is equal to 0. Now the first, all the first, it will be added. Okay, so now what is our task? This is the first one, this is the first one, this is the first one, this is the first one. Then we will just write here alpha 1 plus alpha 2 plus alpha 3 plus 0. Okay, so now comma, after plus you have comma. Okay, now you will take the second one. What is second one? Then the second one is this, then the second one is this, then the second one is this, then the second one is this. Okay, so we are taking the second one. The first is 0, I will not write, neglect it. Then after then alpha 2, then plus alpha 3, then plus alpha 4. Okay, after 2 you have comma. Everywhere you can see that after 2 comma, after 2 comma, after 2 comma. Okay, now we will take the third one, this and this. Okay, the first one is 0, okay, the second one is 0, okay, third one is alpha 3, fourth one is 0. Okay, no problem. This is equal to 0 0 0. Compare. The first one is 0, the second one is 0, the third one is 0. So you are getting alpha 1 plus alpha 2 plus alpha 3 is equal to 0. Then you are getting alpha 2 plus alpha 3 plus alpha 4 is equal to 0. Okay. Then you are getting this alpha 3 is equal to 0. This is equal to 0. This is equal to 0 and this is equal to 0. Okay, we have 3 equations. Alpha 3 is equal to 0, put here. Then you are getting alpha 3 is equal to 0. It implies that alpha 1 is equal to minus alpha 2. Okay, again if you put alpha 3 is equal to 0, then you are getting alpha 2 is equal to minus alpha 4. Okay, so if alpha 2 you will put here, then you will get alpha 1 is equal to alpha 2 is equal to something you will get. Okay, how to find this alpha 1, alpha 2, alpha 3? Are you thinking? Now you know that according to the law, what we are just doing, we have to prove that all must be 0 for linearly independent. Let we are taking, it is not just to not easy to find the value of alpha 1, alpha 2, alpha 3, alpha 4. Let we are just thinking that is linearly independent. Let alpha 4 is equal to 0. If alpha 4 is equal to 0, then you can see that alpha 2 it will also 0. If alpha 2 is equal to 0, then alpha 1 is equal to 0. Already alpha 3 is equal to 0. So it implies that if, because we are independent, we can take any value, okay, in place of this. Alpha 2 is equal to alpha 4, it means that we can take any value. So just let we are taking alpha 4 is equal to 0. If we are taking alpha 4 is equal to 0, then all other are 0. It implies that if all are 0, it implies that in this condition, this is linearly independent. Okay, so for the first condition we have proved. Now we have to prove the second condition, that is the spanning. So let any vector x, y, z, okay, this is belonging to V, our vector, this is belonging to our vector. Now we have to prove vector space, that is VF means vector space. Now we have to prove that this can be generated by the help of this one. So what we will write here, x, y, z is equal to alpha 1, what is V1? V1 is equal to this 1, 0, 0 plus alpha 2, then we have to put this here 1, 1, 0 plus alpha 3, we have to put this here 1, 1, 1 plus alpha 4, we have to put this here 0, 1, 0, okay. Then after then it will multiply here, okay, then comma alpha 2, but here plus alpha 2, then alpha 3, then alpha 3, and then 0, okay, no problem, comma, after then comma, this 0, this alpha 2, okay, this into this multiply alpha 2, this into this multiply alpha 3, plus alpha 3, and this multiply then plus alpha 4, okay. Then the third one, this and this 0, this and this 0, this and this alpha 3, okay. So this is x, y, z. Now compare. So this whole value is equal to x. So you are getting x is equal to alpha 1 plus alpha 2 plus alpha 3, okay. Y is equal to alpha 2 plus alpha 3 plus alpha 4, and z is equal to alpha 3. Put the value here, then you will get something. So what will you get? You have to prove it. The value of you have to find the value of alpha 1, alpha 2, alpha 3. Okay. So now how to just find it? So what we are getting? We are getting by this we are getting alpha 1 is equal to, actually alpha 1 is equal to x minus alpha 2 minus alpha you have alpha 1 x2 x3, okay. So okay, alpha 2 alpha 3, you have x1 is equal to x minus alpha 2 alpha 3, okay. So but you know that alpha 3 is equal to z, so you can write x minus alpha 2 minus z, okay, for alpha 1, okay. So now you can see that alpha 2, what about alpha 2? This is alpha 2 is equal to y minus alpha 3 minus alpha 3 minus alpha 4. What is alpha 3? Alpha 3 is equal to z, y minus z minus alpha 4, okay. So that is alpha 2. So you have alpha 1 is equal to something and alpha 2 is equal to something, okay. So we have got alpha 1 and alpha 2. So there is a problem. What is the problem? Okay, you can also, the first one we have done this, also we can write here you can see that alpha 2 alpha 3, okay. So what we have written, this value we have got from here, okay. We can also write alpha 2 alpha 3 is equal to y minus alpha 4. We can also write it y minus alpha 4, okay. So after then what will happen, we have x, this is equal to y minus alpha 4, okay, but here negative, so this is minus, this is plus, so you are getting this one. So the first one we have got alpha 1 is equal to something and alpha 2 is equal to something. Again we have the problem alpha 4. Let again we are just taking alpha 4 is equal to something. You can take any value. Let we are taking alpha 4 is equal to 0. You can take any value because this is linearly independent. Okay. So if this is 0, then you are getting alpha 1. This is 0, then you are getting alpha 1 is equal to x minus y. And this is also 0. It means that alpha 2 is equal to y minus z. So you got alpha 1, alpha 2, alpha 3 already we have. Okay. So it means that we got what we got? X, y, z is equal to. We have alpha 1. What is alpha 1? Alpha 1 is equal to x minus y. X minus y. Okay. And this is vector v1. This is vector v1. Okay. Then alpha 2. What is alpha 2? Y minus z. Y minus z. This is vector v2. This is vector v2. Then alpha 3. Alpha 3. What is alpha 3? Alpha 3 is equal to z. Z. This is vector v3. And you know that is alpha 4 is equal to 0. So this is a vector. And this vector can be generated by the help of this. This can be generated by the help of linearly combination of scalar and vector multiplication. Okay, if it means that any vector can be generated by the help of linearly combination of vector and scalar. Okay, any vector xyz, it can be anything. You can put any value in place of xyz. It means that any vector in VF can be generated by the help of linearly combination of scalar, that is alpha, that is alpha 1, that is alpha 2, that is alpha 3. Okay, any linearly combination of scalar and vector, that is the linear combination. Okay, linearly combination of scalar and vector. If you are getting this, you can generate. Okay, you can generate. It means that is the spanning. Okay, so that is the exact definition of UK. You can see that these 4 vectors are linearly independent, and also it can generate any vector. Okay, it can generate any vector by the help of this. You can generate any vector. It implies that this is also spanning. It implies that these are the bases. Okay, that is the way to solve. Again, if you have any problem, again I will solve with another question. Then your concept, it will be clear. Okay.